Okay. So I'm going to give now, I'm Tsahi Levy, the person behind BlogGeek.me. I'm going to talk now a little bit about WebRTC. I'm not going to go too deep in the technical side because we only have 20 minutes and some of you know WebRTC, some of you don't. So first of all, thank you for the opportunity for being here, and I hope not to bore you too much. What we're going to talk about first in 20 minutes is what exactly is WebRTC? What is it here to solve? How does it achieve that? The different types of entities in WebRTC, something that usually people miss. It's not only by having something in the browser and you can run off and do things with it. You can, but not much. And then if you want to actually learn WebRTC, where can you go to learn that? Because I'm not going to be able to achieve that in these 20 minutes. So what is WebRTC? If you go and look for the dictionary definition, it will be something like that. WebRTC offers real-time communication running natively from a web browser. That's only part true, and we'll see later why. But that's at least the nature of it. And then if you come from the voice over IP space like me, then for you, WebRTC is simply a media engine that got wrapped with a JavaScript API on top of it. Okay, so we have a standard API on top, a media engine, nothing that interesting. Something to remember, WebRTC is only a technology, it is not a solution. I usually get questions like, well, can WebRTC do this? Well, it can, but not alone. You need to add something to it in order to get there. You can't compare WebRTC to a full service. But you can build a service on top of WebRTC. So it is a piece of technology. Whatever you do with it, that's fine. How are calls made with WebRTC? We've got our two browsers here. You'll see these logos probably along this day a lot. And we've got a server, a web server. Now, the first browser is going to send a message to the server. This server is going to send that message or relay that to the other browser. Now, this is a request, an offer to make a call. The result is going to be that the Firefox browser here is going to send a response, a reply to that, an answer to the offer. And that message is going to get to that other browser. Once that happens, the magic begins, and we've got this line over here that can send any type of arbitrary data. It can be voice, video, or something else. Those of you that know voice over IP look at this and say, well, that's it. We know how to do that. Nothing new here. But if what you're doing is web browsers and HTML code, you look at that and you say, well, I could never send a message directly across browsers. This is fundamentally different than how browsing or browsers worked up until WebRTC. And this is something we need to remember. Now, what goes on 1, 2, 3, and 4 isn't necessarily WebRTC. It's just signaling, which isn't a part of WebRTC. Again, we'll see that later. WebRTC comes with 3 main API blocks. The first one is Get User Media. Get User Media allows you to access from the browser using JavaScript your camera, your microphone, or the screen itself to capture the screen. You can take that data and do whatever you want with it. Leave the other two. Don't do anything with them. You can now take a photo of someone and put it on his profile on whatever social network you want to build with it. MailChimp is doing that already. So there are things you can do with it that don't relate to communication at all. Then you've got peer connection. For me, peer connection is WebRTC. Everything that goes in WebRTC goes in peer connection. It gets you the signaling stuff, or at least the stuff it needs to negotiate what codecs are being used. Is it only a voice call or a video call? Is there a data channel there? Is there more than a single video channel, for example? It sends that data over the line. It encodes and decodes the stuff that you're sending. It does everything. And it deals with NAT reversal. And then there's a data channel. The data channel simply allows us to send whatever type of data we want across browsers without going through any server along the way. These are the types of APIs we have. So why all the fuss? We have a media engine, nothing new there. Okay, you can say that the codecs are the latest ones, not the latest ones, are better codecs. But at the end of the day, it's the same type of technology that exists in any video conferencing solution today and any voice over IP call that you make. So what makes it so different? First of all, it's free. It's open source, it is out there, you can take it, use it, compile it, do whatever you want with it. It's already, let's call it, pre-installed inside browsers. It's wrapped there so you can use it. Before WebRTC, that would have cost you anywhere between $50,000 to $200,000 just to start working with it, not including royalties that you needed to pay. So that's a huge deal. It's a reduction of barrier of entry to new players into this field. If it was only that, I wouldn't be happy. Coming from someone that did in his past video conferencing solutions, that's huge. The second thing is even bigger. This is for web developers, not voice over IP developers. It is a huge difference. I come from a voice over IP space. I've got my upbringing. There are certain things that I know how you do to build voice over IP solutions. So my mind is already narrowed to this kind of thinking. There are many other web developers that don't have these kinds of restrictions built into them. And now we're unleashing this kind of a solution to them. So this is going to change a lot of things out there. Where is WebRTC happening today? We've got Firefox and Chrome, of course, supporting it. Also Opera, not included here, but Opera is also one of the browsers that support it. And then you have Internet Explorer and Safari that don't have WebRTC built into them. There are plugin solutions in these browsers, but it doesn't come natively from the browser. In terms of the history, Chris already said, May 2011, WebRTC was announced. A few months later, near the end of 2011, we had the first browser supporting WebRTC. It supported only parts of it. It didn't really work. The echo cancellation was the worst ever, but it worked. Now, nothing happened in 2012. That seems like a lost year. But I started somewhere in 2012 to actually look at companies that do things with WebRTC. And from beginning to end, we went from a zero number of vendors that use WebRTC to 100 vendors that tinker and build stuff with WebRTC. And that without having a standard at that point, with a single browser that almost didn't work with WebRTC and changed consistently the types of APIs it provided. And still we had 100 vendors. 213, we had Firefox onboarding. Second part of 2013, we had mobile support. Both Firefox and Chrome came out with their Android support for WebRTC. At the end of 2013, it's not here, Opera provided WebRTC on the desktop, and later on at the beginning of this year, on mobile, on Android. If we look at mobile, mobile is tricky for WebRTC. I took the liberty of going to the Google Play Store and look at what gets installed, what people download. So you see the browsers here, the gray are browsers, popular browsers that don't have WebRTC support. The green are browsers that have WebRTC support. So, and that's in the millions or hundreds of millions. Okay? That's not much. We've got more than 1 billion activations for Android today. And the most popular browser is somewhere here at 300 million downloads. And it gets forced on users today. So if you're thinking, well, I'm going to build something, it's going to run on the mobile immediately because I've got it using WebRTC on the web, not going to happen. It will take more time for us to reach there as an industry. I've also taken the liberty to look at what other things people download. So anyone here has Candy Crush on his phone? Okay. We've got only 3 souls that are actually telling the truth. I don't, but I get too many requests to play Candy Crush on Facebook. And then we have Facebook and WhatsApp, messaging systems, communication solutions, and they're somewhere on top of the 500 million downloads. So today, WebRTC on mobile is hard, and I would say that at this point in time, for most of the use cases, it would require an application. So you will take WebRTC, wrap it in an SDK, and then compile it into your application. You can still use HTML5 inside that in many different techniques. And Google already announced at Google I/O that WebRTC is going to be inside WebView later this year with Android L. Okay, so things are improving and improving fast. But we're not there yet. And we're not there yet even in the terms of developers. So yes, we're saying web developers. There's more web developers than voice over IP developers. I took the liberty to look at LinkedIn and see how many people there have WebRTC in their profile. Almost 3,000 people. Voice over IP, more than 800,000. Okay, so we're an abysmally small team of people that look at WebRTC and see that as part of the things that we know how to deal with. Not enough. Going to another hyped technology, big data, not even a technology, only a concept. Okay, not even 1% of that. So WebRTC is not hyped. It is very small, and it's growing nicely if you look at as time goes by. Let's look at the entities of WebRTC. WebRTC, first and foremost, for me at least, is an implementation of SRTP, Secure Real-Time Protocol, with an SDP control mechanism on top of it. SRTP, signaling protocol that is used to send media, voice and video in this case. And SDP is a way for us to explain what it is that we want to send. Other things that exist in WebRTC, we have a media engine, and in that media engine we have an implementation of 3 codecs, 2 voice codecs, G711 and Opus, and 1 video codec, VP8, at least today. In terms of the VoIP implementation, we are using in WebRTC stand, turn, and ice to do NAT traversal. Okay? And we need NAT traversal. We'll see that in a moment. On the client side, this is what WebRTC gives you. Only this part. The rest of the slides in this area are things that WebRTC doesn't provide, but you need to have in your network. On the client side, we have a browser. Chrome and Firefox supporting WebRTC, so that's green for us. Internet Explorer and Safari don't support them, can be solved with plugins in the areas or for the use case that allow plugins. Going on mobile, Android browsers, some of them support it, some of them don't. So we're not necessarily sure what happens when we want to run a use case on mobile in a browser. iOS browsers don't support it. And you cannot support it in an iOS browser today because of the way the App Store is built and the rules that exist there. And then you have SDKs and apps. You can also always take WebRTC, port it into iOS and Android, run your application on top of it, and there are many use cases that are already doing that. If you want a PC application, again, there are SDKs that can run on a PC, and you can wrap your application on top. So you can do a PC application if you want. And if you want to go for an embedded system, you can again port the SDK and use it. So in terms of the clients, you can get availability in many places with WebRTC. None of them are, let's say, the pure WebRTC, which is only the browsers. But we're talking about real-life deployments, and we don't really care if the standard allows it or not, or if that's how it should be or not. Signaling. WebRTC comes with bring your own signaling. Whatever you want to use for a signaling, this is what you're going to do. It means the following. If I want to reach out to you, okay, and do a call with you, now as a developer, someone needs to decide how that happens, because I don't know his IP address. And for me to get that, someone needs to negotiate that. So I have a web server in between that does that negotiation. That server can be a social network. It can be a website that deals with e-commerce, a blog, or anything else that I want. I can use different type of signaling mechanism depending on what it is that I want to achieve. And I urge you to think well before you decide on the signaling mechanism that you are going to use. Usually people will stop here, and then we've got the issue of NAT traversal. And in NAT traversal, there is this minor nuance. Let me find it. Let's see if I can run it. If I check what my IP address is, it's 216 something, blah, blah, blah.
Have you ever
But we can close this one. But if we actually check my IP address, okay, it's actually 192. So I have two IP addresses here. One is an internal IP address that only I know, or the people within my local network know, and there's the public IP address. And if I want to reach out to someone else, or if someone needs to reach me, they need to be able to know my public IP address, otherwise they can't reach me. But I don't know that one. STAN is a protocol that allows us to solve exactly that. It does a similar thing to what I did with the website just a second ago. You ask the question, you go to a STAN server that you know about, you ask him what's my IP address, you get a response, and that generally will create a pinhole in the NAT, okay, where someone will be able to reach me. It doesn't always work, but when it works, it's good. And it doesn't take a lot of networking resources, so most STAN servers today are relatively free. When that doesn't work, we have Turn. Turn will relay that media through a server, an external server that will receive all of the data and stream it to someone else, to the other side, because we can't reach them directly. So we went from a peer-to-peer direct connection to a point where we need to relay that media through a server. And that happens, well, 10, 20% of the sessions. Again, it will depend on the use case that you have and the types of networks you need to go on top. Turn is a bandwidth hog because it sends all the media through it. And this is why these things are usually secured, and you usually don't open them up for everyone. You will only install it and run it for your own use case. So we had signaling. We had STAN and Turn servers. We need to deploy all these three. We might need to deploy other servers as well if we need to deal with other kinds of media. If I want to do a multi-point conference with a large number of people, I might need a server to handle the load for that. I can't do that on the browser clients directly. If I want to do archiving, broadcasting, or any other type of media processing that requires a server, then yes, I will need a server to be added to my solution. WebRTC comes as a client that runs on a browser, and there are other components that you might need to add for your use case on the server side. Now, how exactly are you going to learn WebRTC? I'm a book kind of a person, and there are currently 4 good books about WebRTC. The first one is, well, the WebRTC book. Let's call this one the Bible. This is the first book that was written about WebRTC by Alan Johnston and Dan Burnett. It is now in its 3rd edition. It is a very good book, especially if what you like is understanding standards and the details and the intricacies of a specific protocol. So that's the Bible of WebRTC. Then there's the step-by-step guide written by Rob Manson. This is a getting started with WebRTC book. It's a very good one. It shows how you take WebRTC, connect it into a signaling server based out of Node.js, which is what most of the people do today. Okay, and it just shows how to do that. So if you're one of these guys that just want to get things done fast, this is the book for you. The 3rd book, for me, this is the living room chat. This is one by Salvatore and Simon. It's a new book from O'Reilly. We have a few of those here to give as part of our raffle prizes. Okay, I really like this book because it's natural. You read it and it is as if one of these 2 guys are sitting with you in the room and explaining things to you. So that's the most natural book for me. The 4th one, also a new book, WebRTC Blueprints. This one is for hardcore developers. Don't open this book if you don't know WebRTC already and haven't started playing with it. Okay? It goes deep into some areas. It leaves a lot of things behind, so use it with care, although the information inside it is pure gold. You just need to understand what you're doing with it. If you don't like books and you rather look at URLs, then there's the HTML5 Rocks website, which has several good articles about WebRTC for beginners. There's a WebRTC Hacks website with a lot of stuff for developers, articles coming up every few weeks with good content. And there's the Discuss WebRTC Google group, where people ask questions and Google actually answers. Last but not least, there is the WebRTC Weekly, which Chris and I are running. Go subscribe. You will see weekly links to things happening on the internet that relate to WebRTC. What's Israeli in it? Later. Okay. So thank you. And let's move on to our next speaker.